and go. So that's maybe about it for UML notation regarding class diagrams, and we will continue the exploration of, well, maybe a little bit more higher level design. And we have a new pattern that's called layers or tiers. And the idea of this pattern is to confine changes in one single component or layer in this case. And that maybe we want exchangeable, reusable parts. So we would like to be able to take one layer and remove it and put something else there instead. Or we would like to be able to reuse a layer in other applications. And also that parts are decomposable into coherent subparts. So we can have this large part that we can decompose into smaller subparts also. Typically in our case we have packages, and inside of these packages we have a number of classes. But the idea is that these classes kind of like collaborate closely, and we can define or refine the interactions between the packages, exactly as we had actually in Model View Controller. We could say something about, well, this relationship is legal, this one is not, it should go through this interface is the only thing that's visible, and so on and so forth. And maybe we also need to divide work strictly. Maybe we have experts in our teams, and they should maybe work on the things that they are good at. And the idea here is then to divide the system into coherent layers of responsibility, and let higher layers that are more specific depend on more generic lower layers. This kind of like architecture is something that you find all over the computer science world or software world. Our application, our little dice game, well, it builds upon the console. So the console could be regarded as a lower type of layer that is reusable in many applications, and it's so reusable that it's even part of the standard library of Java. And most other languages also have some form of console input and output. So our application, our dice game, could be seen as a higher layer built upon lower layers and lower and lower and lower, and in the bottom you actually come to the hardware in the system. So at the bottom you have kind of like the screen and pixels and really low level stuff like that. And it's probably some driver in the operating system that is responsible for this. So the Java runtime uses a driver or something like that, and you have a special kind of Java runtime for the Windows system, and that is how they achieve platform independence, because they can have different Java runtimes on different systems, and your system uses just the Java runtime that in turn uses some platform specific thingy. So layers, you can find them everywhere. So classic example of a 3-tier layers for web development, really popular way of dividing stuff. And here we also see an example of the other kinds of views that we have in our architectural diagrams. We have to the left the hardware view, physical view, where we have client computers. If we are doing an intranet, for example, we can maybe have quite good control over the type of client computers that we have. Maybe we can know the hardware specification, or at least some minimum hardware specification that we have access to. We can know how the client computer communicates with our server. Is it over internet? How fast is this communication? We have a server that is in turn speaking to a database server. And well, here we have the LAN with 1 gigabit per second speed. So we have this physical side of things where we talk about how is the hardware actually structured, how is it performing, how many database servers do we have, do they have some communication between them, and so on and so forth. So in the middle we have processes, and on the client computer we decide we will use a web browser. If we do a publicly available application, we probably don't know what kind of web browser we have. Maybe we do some specification that, well, it's not Internet Explorer 6 at least. Maybe we can aim for something higher. However, this one communicates with the Apache server. That is a process that we run on our server hardware. And we use HTTPS to communicate from the web browser to the server. And on the database server, we run MySQL. And to communicate between Apache and MySQL, we use ODBC. So this lets us think about different types of processes where they are deployed on the hardware. Maybe the server and database server is the same machine actually. We have them on the same hardware, but not in this case. And to the far right, we have the development view, where we think about the presentation. The presentation layer runs inside the web browser and consists of JavaScript and HTML. And the logic layer is implemented in PHP, runs on the Apache server. And to communicate between the presentation and logic, we define an API. And in this case, we define a REST API. And to communicate with from the PHP logic to the data that we have in our database in some way, we use PDO and SQL. So using these different views, we can take a look at different types of aspects of our architecture, and we can reason about the presentation layer, or we can reason about the logic layer. And well, we can see that if we changed from MySQL to something else, well, then we probably need to do some re-implementation in our data layer in the development view. And hopefully maybe the logic does not need to change. If it does, if we make some really big restructuring maybe of our go from a relation database to an object database or something like that instead, a document database, we probably need to abandon PDO and SQL and do something else. And then we need to rewrite stuff in our logic layer. But the presentation layer should not be concerned about this. So, thinking about layers and different types of views. And for example, looking in our dice game example, you could, in model view controller, often the model consists inside of it of several different layers. If you have some data storage or things going on in the model, you often have this kind of like, okay, we have the data layer that's responsible for storing stuff on disk or in database or in a text file. On top of this, we have some kind of business logic layer, and on top of this, we have some kind of layer that makes things accessible from the outside in some good and nice interfaces. So often you have like architectures inside of architectures inside of architectures. So layers is something that you will probably use and have used already without thinking about it. And this is also a way to structure your application. The last thing that we will talk about are software components. Software components is a way to reuse and build software using something that is already designed and implemented and tested and deployed. Some kind of cohesive, reusable modules. This is something different than reusing like code or a single class or something like that. That often builds upon either putting the class in some layer, some more generic layer, and then a library of some kind, and then you can use this library. Or copy pasting between different applications. That is not that uncommon. But this is something a little bit larger. It's something that is running, something that is implemented and tested and deployed as a unit, as a component. And we have things like APIs, especially APIs and services that you can access online. That is a type of component that you can use. Libraries, as I said, can also be shipped as components. You can take the library and you can put different libraries together, and you can make an application out of these different libraries instead. And you can test and develop these libraries, or even maybe buy a library from someone else. And we have special technologies for this. We have kind of like HTTP REST interfaces that has become more or less a standard. Before that, we had web services that were really a large standard to standardize communication and to standardize how to create and use interfaces on the web. We have technologies such as Java Beans, DCOM, XCOM, Corba, different types of component standards that are more or less advanced. Yeah, and we will take a look at a small example that I have prepared. The simplest type of component you can think of, especially in Java, you can package your application or parts of your application in jar files. So instead of showing class files, you kind of like put them together in one cohesive part, and this is something you can deploy or distribute or compose in a fairly simple way. I think I possibly will increase the font size here. So something like that maybe. So in our case, I actually took the model that we made, our dice game. I took the model package, and I made two different versions here, one with 2 dices and one with 3 dices. And I put them in a single jar file. And in Java, we are so lucky, so jar files are just zip files. So if we take a look at it, we can see what it contains. It contains some meta information that's not important for now, but we have the model package and we have the classes inside of it. Other types of technologies do this in a slightly different way. Last year we did it in C# and we used DLL files instead. You can't really look inside them in the same way, but if you take a look at last year's lecture, you can see an example on how to do this in C#. Anyway, there are some commands in Java then to package this. I've already done so. It's not really that important for the course, but if you're interested, I think it's JRE is the command, and you have some options, and basically you tell them, take the classes in this package, put them in the JRE file, jar file of this, that with this name. More interestingly though is that, well, I can take and run the Java runtime, and I can tell it to take the dice game model with 3 dices and the console GUI and start it with the program main class. So packaging our program in this way would give us a game with 3 dices and the console GUI. You can see that. So quit. And if I use the 2 dice model instead, we have a game with the 2 dices. So we can kind of like compose our application in this way. And maybe even more interestingly, let's quit. I also made a small graphical user interface. So something like this, really, really cool. So we can have this with 2 dices, and the 7 rule, no. Not lucky today. Or we could run it with 3 dices, and the rule would be 9 instead. Not lucky today. But as you see, a small example on how you can structure your application as components, and you can compose these components differently with each other and make different applications from reusable software parts. So there are different types of technologies to do this more or less with more or less technology support, so that the components can be more or less decoupled. This is possibly the simplest way or the most primitive way to do this. In Java, you have kind of like these Java beans and stuff like that, and they add certain features to the component environment that's running. But this is maybe the simplest form, and in C# and in that platform, like C++, also Visual Studio platform, you can do this with DLL files. So you can tell Visual Studio that this part of the project should be compiled into a DLL file instead, and then I can use this DLL file to ship it to other developers so that they can import it and use public interfaces and stuff from it, or I can compose different DLL files with one executable to run the program in different types of way. So I think actually that is it for today, if there aren't any questions. And well, I have one more administrative task maybe to show. So this was lecture 5, layers, components, and we did a small example, and before that I will also add the refactoring and class diagram stuff. Yeah. The final submission form for the first workshop is online, so you can start adding your final domain models if they are done. tomorrow at 12, they should be handed in. Have a submission form there. And then we have done the first workshop completely finished. And as soon as this deadline has passed, we will start checking the models, and you should get an email to the group responsible if you passed or if you have something to fix. And next week we will start with workshop 2. Hopefully you have already started it, because it's quite much bigger. And some implementation. So if you're not working in a group, I urge you to find a group to work in. There were quite a lot of single entries for the first workshop, so hopefully you can have had some more time to form groups, and also it's free to do that for workshop number 2. And the process will be the same. You will hand in for a passing grade. We will hand out the review groups, and you will make your review and send it to your group before this date, and then we will have a final submission. So it's the same procedure as for workshop 1, and this will be used the same way for workshop 3. All right, questions? Have something here in the chat. And I will also add the source code for the last part of the dice game also to the GitHub repository. We will not focus at least on higher grades for this time. There's a lot of students in the course, so we will focus on getting everyone to know if they're passed or if they have something to fix as soon as possible, instead of giving feedback for higher grades. We will take a look at the interaction diagrams tomorrow. I think we will do a more in-depth example then also. So I think 5 minutes is not enough time for this. I can maybe give you a small tip. Websequencediagrams.com. It's kind of cool. So you can take a look at least some notation here. Are we allowed to use YAX-RS to marshal, unmarshal to JSON to have the data in XML, for example, for workshop 2? Yeah, you're basically allowed to use any kind of like libraries and stuff like that you want to. I don't want you to use any frameworks though for kind of like the application architecture. So basically that code should be your own, but you're allowed to use any type of libraries and stuff like that. And well, frankly, just serializing stuff to JSON or XML or something like that is not that interesting from a design standpoint. So use any libraries you can get your hands on regarding that, because it's just tedious and boring to implement yourself and error prone. Oh, you can probably have different styles. I kind of like this sketchy. Another tool that is often used is YUML.me to make class diagrams, and I think they are quite good. You can do most things you want to do. There are some limitations, especially if you're doing domain modeling. You can't write kind of like the association name, and I like that they have köttbullar. But otherwise you can probably do at least the design work you need to do in this way. And the neat thing about this, I think, is that it's like text-based. So you can save these texts and modify them quite easily, and you don't have to have a big application with drag and drop, and well, it just becomes messy, and well, you have less control over layout, but I think that's maybe an advantage. Otherwise, it's easy to start dwindling over, oh, this should go here and this should go there, and working with the layout actually overwhelms you, and you spend more time worrying about layout than you do about actually modeling. Any more questions? All right, then we end for today. Thank you and bye for now.